Okay, we're now recording and share the screen. All right, so just about everybody was okay in the quiz yesterday, and I should have replied back. If you didn't get a reply back from me on the quiz, let me know, but almost everybody got it right. And we're gonna have another quiz tomorrow. We got a short week. Thursday, we have no class, no CSM classes at all. It's a flex day. So teachers have meetings, but you don't have to show up. So that being the case, we're already here. Okay, so we only have one section left for the upcoming exam, 10.2. There are two more formulas. One is called the Law of Sines, which I believe is 1 through 15. And then 19 to 35, Law of Cosines. Okay, you don't have to write that down yet, and it's in the book. So my main focus today would be on the Law of Sines, and maybe I'll sneak in a little bit of Law of Cosines. And then tomorrow, Law of Cosines, and I'll give you a quiz on that. Okay, so my goal is to finish all of chapter 10. Well, I say all, there's only two sections. So finish 10.2. So at the end of tomorrow's class, hopefully I would have covered everything you need for the exam next week, Thursday the 29th. Whatever I don't finish, I can still move into Monday. But as I said before, I may just go ahead and get started with our last exam material. So once I finish 10.2, then we're down to our last exam, and you'll be happy to know there's no more trig after that until the final exam. So I have all of this to cover in the remaining weeks. There'll be a test on that, and then we have a final exam. So we're getting near the end, folks. Almost done. Yes, I was finished with 10.1, so I'll go to 10.2 now. Okay. All right, so any quick questions about what's happening? Okay, so reminder, no class on Thursday, therefore I will give you another quiz tomorrow. Next week, I'll do more stuff, and maybe Wednesday, I'll let you have time for questions and answers. And then same as before, Thursday. Oops, I'm over here. Yeah, Thursday will be the exam. I may lecture a little bit, as I tend to do on exam days, and then let you ask questions, and then we'll go to take the test. Right, so let me check the chat to see if there's any questions right now. Okay, yeah, if anybody just joined, put yourself on the chat and I'll get you later. Okay, and okay, can the final exam be considered one of the dropped exams? No, it's not. Actually, technically, that's even not totally correct, but yeah, you should not skip the final exam. So if you did well on all the previous exams, you still need to take the final exam. This gets a little bit complicated, but if your final exam turns out to be your worst, you get to drop part of the final exam, but not all of it. Okay, so if you want to say it in short, you should not skip the final exam. Is the best way to do it. But it is to your advantage to take all the other exams and do well on all of them. Because if you do, if your final exam turns out to be the worst, you get to drop a portion of the final exam. Okay, so I think that answers that question there. And I think I've caught up with everybody else in the chat. Okay, any other questions before we get started, please? Okay. All right, so Law of Sines, Law of Cosines, 10.2. And I don't really know why it's all in one section. Many books have it in two sections, Law of Sines, Law of Cosines. Okay. I will go over the derivation of the Law of Sines. I will not go over the derivation of the Law of Cosines. It's a little bit tougher. Okay, but you do Law of Sines and Law of Cosines now for any triangle. It doesn't have to be a right triangle. Okay, any old triangle will do. So let me show that. So Tuesday the 20th, 10.2. We'll start off with the Law of Sines. And I'll show you a derivation of the Law of Sines. Okay, so you do not have to have a right triangle. It can be any triangle. So let me just make up any triangle. Okay, so there's no right angle necessarily. So let me label A, B, and C. There's no right angle. And maybe the way I drew it, it looks almost like equilateral, but it's not. pretend that all three sides are different. Okay, first of all, convention. Okay, for the three sides, little a is opposite capital A, little b is opposite capital B, little c is opposite capital C. So it goes like this, A, B, and C. So the convention for a general triangle is angle A opposite side A, angle B opposite side B, angle C opposite side C. So capital letters for the angles, little letters for the sides. Okay. Now you don't have to put A, B, and C like this, right? Obviously I can put A here, I can put B here and C here, but wherever you put the capital letters, then you go across for the little letters. Yeah, I mean, I guess an easy way to explain it is I could just turn this and now A is on the top, and I can turn it like that and now B is on the top, right? But no matter how you situate it, right, big B is opposite little b, big A is opposite little a, and so on. Okay, so I want you to follow the convention. Right, so maybe in general, so one way to think of it is you can randomly put down, okay, make up a triangle like that. Yeah, I put A, B, C like this. You don't have to do that. You say, oh, I want to put A here, and I want to put B here, and I'll put C here. You're allowed to do that, but once you do that, can you tell me where little a has to be? Little a has to be here. What does this have to be? Little c, and this is little b. Okay, so that's the convention. Okay, angle A opposite little a. And by the way, similarly, you can plunk down the little letters, the sides first. So make up some random triangle. Okay, you could say, I want the distances first, right? So you can say, I want this to be, I don't know, this is little a, and I want this one to be little b. I want this to be little c. Okay, but again, once you do that, then the points are determined, right? So for instance, think to yourself, what must this be? Has to be big B, because it's opposite little b. Okay, all right, and can you tell me where do I have to put big C? Where does big C have to go? Has to go here, opposite little c. And big A has to be here. Okay, so you have a little bit of freedom in labeling. So you can plunk down A, B, and C capital anywhere you want. But once you do that, little a, B, and C are determined. And likewise, sometimes you can just plunk down little a, B, and C anywhere you want, but then you have to put the capital letters always opposite, okay? So little a always opposite big A, and etc. Meaning little b opposite big B, little c opposite big C. Okay, so capital letters for the angles and little letters for the sides. So we say angle A is, I don't know, 57 degrees, and that is 43 degrees, and this is 90 degrees or whatever. And the sides are A is 10, B is 13, and C is 17 or something like that, okay? All right, so now a derivation for the law of sines. Okay, I'm going to try to reproduce this picture here to a certain extent. And yeah, the way I drew it, it was kind of equilateral. I don't want you to think that it's equilateral. So make it go like this. A, B, C, little a, little b. And I know this is little c, but I'm not going to put it right now because it clutters up the picture. Okay. All right, I'm going to drop a perpendicular, which I'm always able to do in general. I'll make a right angle here. I'll call this X. Okay. Where did it come from? I just made it up. I mean, you can see if I'm on point C, I can obviously come straight down to make a right angle X. So again, even though your original triangle doesn't look like a right triangle, you can make a right triangle by playing this game over here. Okay, so let's do our SOHCAHTOA. Can you tell me what's the sine of A using this triangle right here? This triangle right here. Opposite over hypotenuse. X over B. Okay. Multiply both sides by B. X is B sine of A. Agree? Okay, similarly, look at this triangle, it's a right triangle. What should be the sine of B, big B? Opposite over hypotenuse, x over a. So multiply both sides by a. Okay, you agree with that? All right, x is b sine a, x is also a sine b. Okay, maybe you had this in high school geometry. If two things are equal to a third object, they have to be equal to each other, right? In high school geometry, that you may have heard that as the transitive property. Ever have a transitive property? If two things are equal to a third, they have to be equal. So I claim that b sine a and a sine b are equal to each other. How come? Because they're both equal to x. Does it make sense? So that means b sine a equals a sine b, because they're both equal to x. All right, now I'm just going to divide both sides by AB. Divide by AB. Divide by AB. B cancels here. A cancels here. Sine A over A equals sine B over B. Very nice formula. Okay, and I'll just say similarly, you can play the exact same game. The algebra and the trig is exactly the same to get C into the mix. Okay, so we have the law of sines now. Okay, can you guess what the third part would be? Sine A over A, sine B over B, sine C over C. Yes, so from the beginning, you could, instead of drawing this, I could draw this one, right? And go across like that. The analysis is exactly the same. You're just changing letters, okay? And you would get sine of C over C in the mix too. So here's our law of sine. Sine of A over A equals sine of B over B equals sine C over C. And here is the law of sines. Put it on your cheat sheet. Okay. If we were meeting face to face, I'd make you memorize it. But there's the law of sines. Okay, now you're not responsible for this derivation. You might have said, I don't know what you were doing over here. That's okay. Some of you might have understood. It's part of my responsibility as a teacher to show you where it came from. But what are you responsible for? Using this. Okay, sine A over A equals sine B over B equals sine C over C. And where is it? Page 682. There we are. Sine A over A, sine B over B, sine C over C. See where it says equivalently? Sometimes you see it written in that fashion, and it's the same thing. They flip it. A over sine A, B over sine B, C over sine C. Okay. Okay, so we're ready to get started with some of these. So you can use this to solve a triangle. Okay, first of all, something you should recall from high school geometry. If I have any triangle, A, B, C, angle A plus angle B plus angle C always adds up to the same number, which is 180 degrees. Right? So yeah, most of this section is going to be in degrees. So if you have your calculator set to radians, change it to degrees. In fact, I better do that right now. So this section, law of sines, law of cosines, is all degrees. So let me check my mode here. Yeah, last time I did this, I was in radians from my calculus class. So I've switched back over to degrees. Okay, so now I'm in degree mode. And on this calculator, let me make sure I'm in degree mode. I'm now in degrees. So for those of you with this calculator, DRG stands for degrees, radians, gradients. Shoot that again and hit it. It's now radians. Hit it again. I'm in gradients, which I'm not even going to talk about. And hit it again. I'm back to degrees. Okay, so there it is. I'm in degree mode. for both of them. Okay, so we can use this to solve triangles if possible. Okay, there'll be times where this is impossible, in which case you have to do the other law, something called the law of cosines. Okay, so the problems that we're going to be doing are solving a triangle. And what does it mean to solve a triangle? Give all three sides and all three angles. And normally you'll be given three pieces of information. Usually we have 3 of the 6 pieces of information. That's typically what happens. Okay, so given some information, solve the triangle. That means give all three sides. So a completely solved triangle. Say, okay, this distance is 25, and this is 42, and this is 30, and this is angle is 73 degrees, and this is 91 degrees, and this is 42 degrees, or whatever. That's solving a triangle. Okay. Usually they'll give you 3 of the 6. So they might give you 3 sides, or they give you 2 sides and 1 angle, or they give you 1 side and 2 angles, or something like that. Okay. And then you have to solve for the rest of the triangle. Okay, so let me just try to show you what we are up against. So find answers to 1 decimal place or whatever. So look at number 1. They give me 2 angles and a side. Number 3, 2 angles and a side, right? And find something else. 2 angles and a side. Find A and C. Okay, number 7, they give you 2 sides and an angle. Right? Okay, so let's get our feet wet. All right, so 1 to 15, 19 to 35, 10.2, 1 to 15, 19 to 35. So let me show that to you for those who don't have the book and aren't planning on getting it. So page 689. Okay, so there's problem 1 and 3. Five, 7, 9, 11, 13, 15, and then, okay, directions at the bottom, there Lewis law of cosines, which I have to show you later. Okay, so here's 19, A and B, I guess. 21. And now I forgot how far we're supposed to go up to. 35. 23. 25, 27, 29, 31, 33, 35. Okay. So we'll see how much I'm willing to do of these. All right, so 1 and 3 are similar. I'll do 1. Angle A is 60 degrees. Angle B is 45 degrees. BC equals 12 centimeters. Find AC. All right, so let me just draw a triangle. See on that? Okay, I like to go A, B, C. Once I do that, this has to be little a, little b, little c. All right, so let's put down stuff. BC, that's little a, is 12 centimeters. Angle A is 60 degrees. Angle B is 45 degrees. And they want you to find the distance from A to C, which is little b. Okay, and while we're at it, let's find angle C. That should be easy, right? Let's get that out of the way. All three of these have to add up to 180. So angle C is 180 minus 60 minus 45. That comes out to be 100 and something, 105, so 75 degrees. All right, so they're asking us to find AC, which is little b. Okay, I have big A, little a, and big B. Okay, so sine A over A equals sine B over B. Plug in stuff. Sine of 60 degrees divided by 12 equals sine of B, sine of 45 degrees over little b. Cross multiply. We're going to do the cross multiply rule quite a bit. Okay, remember the cross multiply rule? If you have a fraction equals a fraction, that times that equals that times that. Okay, so I'll set you up with that tomorrow. So cross multiply rule. I'm sure you've seen that before. If A over B equals C over D, you have a fraction equaling a fraction, then you can go across like that. Then AD equals BC. Cross multiply rule, right? I'm sure you've seen that before. A mathematical justification is you can multiply both sides by BD. If you multiply this by BD, it looks like that. If you multiply this by BD, the common denominator, it looks like that. Okay, so I cross multiply. B sine of 60 degrees equals 12 sine of 45 degrees. B sine of 60 degrees equals 12 sine of 45 degrees. Okay, I'm solving for B, so divide both sides by sine of 60 degrees. Sine of 60 degrees, sine of 60 degrees cancels. And here we go. Answer to 1 decimal place. All right, so make sure you are in the correct mode. So quick double check, I'm in degree mode, as you can see. So if you're in radian mode, change the degrees. Okay, so what do I want? 12 sine 45 over sine 60. 12 sine 45 divided by sine 60. 9.79, blah, blah, blah. So they said 1 decimal point. So that means 9.8. Is that right? .8 centimeters. Or you can say that's, AC. Specifically, they asked for AC. So AC means the distance from A to C, or you can use a little letter B. Okay. So that's that. Okay, number 5. Show you that one. Number 5, angle A, angle B, and little b, find little a and little c. Okay. So draw my triangle, right? A, B, C. You say, do I have to put A, B, C here? No. If you like that to be A and you like that one to be B, you like that, that's okay. But once you do that, the little letters have to go opposite, right? So little a, little b, little c. Okay, now what do they give me? Angle A is 36 degrees. Angle A is 36 degrees. Angle B is 50 degrees. And little b is 12.61 centimeters. Again, that's typical. They typically give you 3 pieces of information, find everything else. Okay. Again, usually when they give you 2 angles, you immediately solve for the third, right? So that's easy. 180 minus the sum of these 2. So angle C is 180 minus 36 minus 50, right? So what is that? 180 minus 36 minus 50, 94 degrees. Okay, set up my law of sines. Sine of A over A, sine of B over B, sine of C over C. Okay, so big A, little a. Big B, little b, but I know little b, 12.61. And let's see, big C, little c. All right, in directions it says find little a and little c. Okay, so even though they give you 3 fractions, just use what you need. So if I'm solving for little a, cross multiply here. If I'm solving for little c, cross multiply here. And there are instances where you ignore the middle, you're allowed to do that. And you can cross multiply going this way too. Right? You can just eliminate the middle one and you're allowed to cross multiply that times that and that times that also. Okay, so cross multiply here. A sine 50 equals 12.61 sine of 36 divided by sine of 50 divide sine 50, cancel, cancel. Round to the nearest tenth. And we're doing centimeters. Okay, so what is it? 12.61 sine of 36 divided by sine 50. 12.61 sine of 36 divided by sine of 60. Oops. Oh, 50. Yeah, it is 50. 9.67 means 9.7 rounded off. Okay, so A is now 9.7 centimeters. And now to find little c, I ignore this and cross multiply here. That's all there is to it. Right, so c sine of 50. Oops, I didn't want that to be in red. C sine 50 equals 12.61 sine of 94 degrees and divide by sine of 50, right? Divide sine 50, cancel, cancel. So C is so many centimeters. Okay. So 12.61 sine of 94 divided by sine of 50. 16.4. And there we go. So this is called solving the triangle. You give all the sides and all the angles. I now have all the sides, 12.61, 9.7, 16.4, and I have all the angles. So it's completely solved. Okay, the problem's finished, but I'm going to dig a little bit deeper. You might be wondering, hey, I already got two sides. Couldn't I have just used the Pythagorean theorem to find the third side? Sounds reasonable. Pythagorean theorem. You cannot use the Pythagorean theorem here because the Pythagorean theorem only works for what kind of triangles? Right triangles. There has to be a 90-degree angle. There is no 90-degree angle, so you cannot use a squared plus b squared equals c squared. Okay. All right, one other thing to notice. Which is the largest angle? 94 degrees. Which is the largest side? 16.4. Which is the smallest angle? 36. Which is the smallest side? 9.7. That will always be true. Okay, so the largest angle is opposite the largest side, smallest angle opposite the smallest side. Okay, so I'll put that down here. Largest angle is opposite largest side. Largest angle is opposite the largest side, and likewise the smallest angle is opposite smallest side. Largest angle is opposite the largest side, smallest angle is opposite the smallest side. And this kind of gets evident if I do real extreme examples. Suppose I have a triangle like this, right? It's really scrunched in like this. Can you see this is a very small angle, right? And that's a very small side. Okay. Now imagine taking these two and opening it up. You go like this, right? Okay, you have a very small angle. Then I open it up. As I make the angle bigger, I don't have any more hands, but this opposite side gets bigger also, does it not? So it'll end up looking like this, right? So the angle gets bigger and bigger and bigger, and then that obviously makes this opposite side gets bigger and bigger and bigger, right? So this is a little double check, okay, that you did it correctly, perhaps. Well, it's not a guarantee you did it right, but it's one way you can double check. Is the largest angle opposite the largest side? Is the smallest angle opposite the smallest side? Okay. Okay, I'll try to show you number 7. All right, so they give me all this. I'll make up a triangle again. By the way, when you first make your triangle, obviously you don't know which one's the biggest and smallest, so don't worry about that. It doesn't really matter. In other words, halfway through the problem, you might say, the way I drew it, this one was smaller than this, but it's actually bigger, right? See this? I didn't know that ahead of time. Don't worry about it. It'll still work out. So don't worry if your triangle's not to scale, right? I mean, this is 9.7, this is 12.61. Look at, hey, that looks like it's smaller than that, but it's supposed to be larger. Yeah, we didn't know that ahead of time, right? I have no way of figuring out ahead of time until I actually do the problem. So don't worry about the relative sizes of the triangle as long as you get it, you know, the opposite and all that kind of stuff. So I won't, in other words, I won't take off points for that. All right, so yeah, let me do this. So that's little a, little b, little c. Okay, so for problem 7, what did it give me? Little a is 29.45 centimeters. Little b is 30.12, also centimeters. Angle B is 66 degrees. Find the remaining angle and size of the triangle, number 7. Solve the triangle, in other words. Okay, so again, notice they give you 3 pieces of information, right? 1, 2, 3, 2 sides and an angle. Find the rest. All right, so sine A over A, sine B over B, sine C over C. Sine A over little a, 29.45. Sine B over B, sine 66 over 30.12 equals sine C over little c. Right. So what's my strategy? Right now, I don't have any information on C. So this is hopeless. But over here, I can figure out angle A first, right? I have all the information on the B's. I have one of the A's. So I'll use this. So once I find angle A, so here's the strategy. Once I find angle A, pretend I find angle A to be, I don't know, 70 degrees. Can you see what the strategy would be after that? Find this, right? Because then all three of these have to add up to 180. And then I use the law of sines to figure out little c. So that's the strategy. Okay, so let's cross multiply here. 30.12 sine of A equals 29.45 sine of 66. Divide by 30.12, divide by 30.12, cancel. So sine of A is all this stuff. Okay, so here we go. 29.45, 29.45 sine of 66 divided by 30.12. .8932, something like that. Okay, now that's not A, that's the sine of A. How do I get just A? Inverse sine, at least that gives me one angle. Inverse sine or arc sine, 0.8932. Now, since if I have an answer key, okay, I don't have to type this all in all over again. I'll just do second function, inverse sine of the answer. So if your calculator has an answer button, you don't have to type this all out. Just do inverse sine of answer. That's the same thing as if I type 0.893224, blah, 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 blah. 63.28, let me call it 63.3 degrees. So I'm going to put 63.3 here. But there could be a second quadrant angle. Okay. The y coordinate is 0.89, whatever. This is 63.3 degrees. We also have to figure this angle out. Okay, so you might have two possible triangles. So how do I figure this? This is 63.3. So 180 minus that. Okay, so 180 minus 63.3. $116.7. However, let's see, is that viable? My first angle was 66, right? 116.7 plus 66, that's already greater than 180 degrees. I've surpassed my quota of 180. 182 degrees, 183. So this is not possible, although you do have to check for this in general sometimes. Okay, you have to check the second quadrant angle. In this case, not possible, so no worries about it. Okay, so this is no good. All right, now figure out angle C and go from there, right? So angle C is 180 minus 66 minus 63.3. Okay, so I got that. Figure this out. Okay, so 180 minus 66 minus 63.3. 50.7. Yeah, so now I know this is 50.7. Okay, then cross multiply here, and then I should be home free, right? Go that times that times that. So C sine 66, C sine 66 is equal to 30.12 sine of 50.7. C sine of 66, 30.12 sine of 50.7, divide by sine of 66, divide by sine of 66, and we are done. Okay, so 30.12 sine 50.7 divided by sine 66. 25.5 centimeters. And we got it. Okay, the triangle is solved of all the sides of all the angles. Okay. And yeah, let me double check this rule before we break. Okay. Largest angle opposite the largest side, smallest angle opposite the smallest side. Okay, largest angle, 66. Largest side, 30.12, yes. And smallest angle, 50.7, smallest side, 25.5, yes, that's correct. Okay, so this is some of the law of sines. Let me do my focusing thing and then we'll break. I'll continue with more law of sines, but I want to at least sneak in the beginning of the law of cosines also, so you have it ready for tomorrow when I give you the quiz tomorrow also. So here's everything here. And, whoops, there's that. Yeah, if anybody joined late on any given day, if you join late, put your name in the chat so I can get you for attendance a little bit later. And there's all of this stuff. Okay, so there we go. Okay, so break until 12:10 as usual. All right, thank you. Okay, folks, we're going to pick up where we left off. So we're doing the law of sines. I'll do some more law of sines and sneak in some of the law of cosines. So law of sines, page 682. Sine A over A equals sine B over B equals sine C over C. Okay. Okay, number 9 is a little bit unusual. Let's go ahead and work them out. Okay, but basically you don't have to draw a triangle for these. We just answer the question based on what we know from trig, essentially. Okay, so I'll just put down the highlights of what we need here. So number 9, A. Sine of B is radical 2 over 2. Then it says, what are the possible values for angle B? And I'll go ahead and add, sometimes the text uses angle B. I'll do that too. But if I just put capital B already means angle B because little b means the side. All right, sine of B is radical 2 over 2. Well, we know that B can be 45 degrees, but there's another angle over here. Right, so you have to consider first and second quadrant. So that's 45 degrees, and this one is 135 degrees. So you could have more than one angle which satisfies this equation, right? A 45-degree angle, 135-degree angle. Okay, 9b, cosine of E is radical 2 over 2. Okay, this time there's only one angle, because if you look at the unit circle, cosine is positive in quadrants 1 and 4. But you know you're going to have a negative angle for these kind of things. And what about this angle all the way here? That's past 180 degrees. So you're only going to have one angle in this case. Angle E is pi over 4. Okay, so whereas sine of an angle being a positive number, you possibly could have two angles. Not so for the cosine. Okay, there's just going to be one such angle. Okay, C, sine of H equals 1/4. Y coordinate is 1/4. Okay, my calculator is going to give me this one. We have to figure out this one. Okay, so H is inverse sine of 1/4. Why don't I type in 0.25? That's probably a little bit easier, right? 1/4 is 0.25. Okay, so inverse sine. Let me check my mode. Am I in degree mode? Yes. Inverse sine of 0.25. I'll say 14.48 degrees. Round it off. But what's the second quadrant angle? It's 180 minus 14.48 degrees. So 180 minus 14.48. Okay, second quadrant angle would also work. 14.48, by symmetry, this is 14.48. So the angle in standard position, meaning this is 0, this is 180, so 180 minus 14.48. 180 minus the answer. 165.52. Okay, and finally D. Cosine of K is negative 2/3. Once again, I don't have to worry about ambiguity for the cosine because cosine is negative in what quadrants? All students take calculus. Negative in quadrants 2 and 3. Okay, but I can't have a third quadrant angle because that's already past 180 degrees. You can't have any angle more than 180 degrees. So I must be having just a second quadrant angle, and that's it. So K is inverse cosine of negative 2/3. So there's only one such angle. So again, for cosine, inverse cosine, only what's one such angle. Sine and inverse sine, you might have two possible angles. Now, back in this problem, we had to throw one of those angles out because by keeping that other angle, right, 116.7, that already brought me past my quota of 180 degrees, right? One angle was known to be 66, so this was impossible. Okay, inverse cosine of negative 2/3. Inverse cosine, parentheses, negative 2 divided by 3. 131.81 degrees. And there we go. Okay. 13 is a little bit funnier question. See why. I'm sorry, 11. Let me do 11 first. Show that there is no triangle satisfying the conditions A is 2.0 feet, B is 6.0 feet, angle A is 23.1 degrees. So they're saying no such triangle exists. How do you do that? Well, let's just start as normal. Do everything according to plan. A, B, C, little a, little b, little c. Okay. Little a, 2.0 feet. Little b, 6.0. Then what do they say? Angle A, 23.1 degrees. Okay, they're saying that this triangle is impossible. How do you do that? Well, let's set up law of sines. I don't have little c or big C. I do have A with A and one of B's. Okay, so sine of A over A, sine of 23.1 over 2.0 equals sine of B over 6.0, right? Now, I could cross multiply, but I'm noticing, hey, I'm trying to isolate sine of B anyway. Why don't I just multiply both sides by 6.0? And that cancels out, right? 6.0. So sine of B is 6 sine 23.1 divided by 2.0. Well, 6 divided by 2 is 3. So it's basically 3 sine of 23.1 degrees. Okay. 3 sine 23.1. 1.18. Sine of the angle is 1.18, i.e., on a unit circle, the y coordinate is 1.18. Well, that's impossible because the y coordinate on a unit circle has to be between -1 and 1. Right? You can't have the sine of an angle being 1.18. So no such triangle exists. Impossible. Okay. All right, so that's it for that one. Then let's see, I think I'll show you 13. It's a little bit harder. Here's a case where there's two triangles. Let B equal 1, A equals radical 2, angle B is 30 degrees. Use the law of sine to show blah, 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 blah. Okay. So here's the case where there are going to be two such triangles. A, B, C. Again, you don't have to put A, B, and C where I do, but once you put them down, you have to go opposite. You must go opposite for the little letters. Okay, B is 1. A is radical 2. Angle B is 30 degrees. Okay, so I don't have C or C. I have one of A's, both of B's. So here we go. Sine of A over little a, radical 2. Sine of 30 degrees divided by 1. Well, if you divide by 1, you don't have to do anything. Multiply both sides by radical 2. Sine of A is, sine of 30 degrees is a half times radical 2. Radical 2 over 2. Well, for my unit circle, what angles are those? That's 45 degrees and 135 degrees. Is 135 too big? No. So in this case, there's actually two triangles that work. So that's what they're trying to say. So part A, angle A is either 45 or 135. So part B, assume that angle A is 45, determine the rest of triangle ABC. Part C, assuming the angle A is 135, determine the rest of parts of triangle ABC, and then find the areas of the two triangles. Okay, so part B, I'm going to piggyback off of this. Okay, so let's assume this is 45 degrees. 45 plus 30 is 75. 75 from 180, so that makes this 105. Right? Okay, then sine of 30 degrees over 1 equals sine of 105 divided by C, little c, cross multiply. C sine 30 degrees equals sine 105 divided by sine 30. Okay. So sine of 105 divided by sine of 30. Sine 105 divided by sine 30. Alternatively, if you already know sine of 30 is a half, you can just type in a half there, or 0.5. 1.93. Then it asks us for the area. So for the area, I have to use that formula that I used last time. There was only one problem like it, but it looks like we got more. One half AB sine of C, sine of the included angle. So let me go back and show that to you. Page 666. Area is 1/2 AB sine of theta, where theta is the angle included. So you're allowed to pick either of these. How about I pick this, this, and this? So 1/2 of 1 radical 2 sine of 105. Okay, so you look at the picture. 1/2 AB sine of theta. Theta is the included angle. A and B are two sides. So I'll pick 1. It's always nice to pick 1. I like multiplying 1. Radical 2 was given, and the sine of 105. Okay, should box this off here. All right, so square root of 2 divided by 2 times the sine of 105. 0.683. Okay. I did square root of 2 divided by 2, 0.707, and then multiplied by the sine of 105, 0.683. And then they're saying, what if you have the other triangle where A is 135? Okay, so A is either 45 or 135. So if I have 135, the picture actually looks more like this, I guess. So B is 1, A is radical 2, here's little c, and this is 135 degrees. So it's much more exaggerated as an angle. This is still 30 degrees. C, A, B. All right, so that's going to be 135 plus 30 is 165. 180 minus 165 is 15. Okay, so angle C is 180 minus 135 minus 30, which is 15 degrees. Okay, so how about sine of what? Sine of B over B. I might as well use 1, makes the calculation easier, right? Sine of 30 divided by 1 equals sine of C over C, 15 degrees divided by C. Cross multiply. C sine of 30 equals sine of 15 divided by sine of 30. Cancel. All right, so sine 15 divided by sine of 30. Sine 15 divided by sine 30. 0.52. It's about 0.52. Oh yeah, double check here. Let's see. This came out to be 1.93. Square root of 2 is about 1.4. So largest angle, largest side, yes. Smallest angle, smallest side, yes. Here, Largest angle, largest side, 1.4, that's correct. Smallest angle, smallest side, that's also correct. And using the area formula again, same one. 1/2 AB sine theta. Why don't I just do the same thing? 1/2 of that times that, sine 15. 1/2 of 1, I like 1. Radical 2, sine 15 degrees, whatever that is. Okay. So square root of 2 divided by 2 times the sine of 15. 0.183. Okay. All right, that's as much as I was going to give you for the law of sines. It's only 12:30. I'll just introduce the law of cosines and then I'll be pretty much done. Tomorrow we'll do the law of cosines and I'll give you a quiz on that stuff. But now the law of cosines, 10.2. So page 684. Here they are. I decided not to go over the derivation for you. Now it looks like 3 formulas. They're really all the same. It's 1 side squared equals the other 2 sides squared minus 2 times each of these cosine of the same letter as what you have over here. So if it looks like 3 formulas, it's sort of really this. Okay, and again, if you were meeting with me in person, I'd make you memorize it, but you only need one of them. A squared equals B squared plus C squared minus 2BC cosine of A. So after the minus stuff, so you have 1 side squared, right? Take the sum of the square of the others, B squared plus C squared, and then minus 2, copy these letters, and then cosine of that one. Okay, so you can guess. It's kind of hard for me to do this. If you had B squared, just follow the logic here. A squared plus C squared, or C squared plus A squared, minus 2 times the other letters, 2AC cosine of B. And then same thing, C squared. The other 2 letters, A squared plus B squared, minus 2AB cosine of C. And they give you a sample triangle again, A, B, C, little a, little b, little c, little a opposite big A, little b opposite big B, little c opposite big C. Law of cosines. Now you can see it's a much harder formula. So you might say, why don't I just always do law of sines? Simple reason, sometimes you can't do the law of sines. You'll find yourself stuck if you try the law of sines in some instances, in which case you have to do the law of cosines. Okay, so if you want to put all 3 on your cheat sheet, you may, but if you understand what's going on, you can survive with just one of them because these are all equivalent. You're just kind of relabeling what's happening here. Okay, I'll just say off to the side here. Suppose angle C is 90 degrees. Suppose it's 90 degrees. It means you have a right triangle. Cosine of 90 degrees is 0, which means that's 0. That wipes all this out. And you have your Pythagorean theorem. C squared equals A squared plus B squared. Okay, so you can think of the Pythagorean theorem as a special case of the law of cosines, right, where angle C is 90 degrees, and equivalently for the others. Okay, now, this looks much harder than this. So you say, why don't I always use this? Sometimes you can't. Okay, let me see if I can show you one instance where you can't. All right, so maybe I'll show you 1, 2 at the most, and then I'll quit. Okay, so I'm done with the 1 to 15. Now 19 to 35. Of course, it tells you to use the law of cosines, but suppose they don't tell you. Okay. So 19. Well, they have 19A and B. Okay, I'll just do one of them. 19A. "60 degrees, 5 centimeters, 8 centimeters, X." Now, even though they give you this and they don't give you any letters, you can always sneak in letters. Okay, so why don't I just sneak in the letters that I'm used to? Capital A, and I should actually put this in red to be consistent. All right, change the letters. Capital A, capital B, capital C, little a, little b, little c. Okay, let me just show you what happens if I did law of sines, that we would get stuck. Okay, so sine of A over A, sine of 60 degrees over A. By the way, I'm going to quickly cross this out, but I'll cross that out lightly to show you we don't want to do that, but I'll show you you get stuck. Okay, sine of B over B, sine of angle B over 5 equals sine of C over 8. This is what I would have. And by the way, it's a true statement, but I'm stuck. I can't solve for any one letter because any way I cross multiply, notice you have 2 variables because you have exactly one of each letter. I got 1A, 1B, and 1C. Anytime you have just 1A, 1B, 1C, you're stuck. Well, I take it back. Unless you have 2 angles. If you have 2 angles, you're going to automatically get the third. Okay, suppose I try to cross multiply here. That times that times that. I can't do it because I have 2 variables. I have little a and a big B. Okay. Suppose I try to go here. Cross multiply. I got a big B and a big C. That's not going to work either. Okay. And what if I do the 2 extreme ones? Okay, I go that times that times that, but I have a little a and a big C. So in each case, when I cross multiply, I have 2 variables, so I'm stuck. Okay, so when do I use the law of cosines? When the law of sines is impossible. Okay, so use law of cosines when law of sines doesn't work. Okay, so how do I do this? Okay, so here's the way the formula works. A squared equals B squared plus C squared minus 2BC cosine of A. Okay, so that's the formula from over here. Law of cosines. It's 3 forms, all equivalent. So how do you know which one to pick? Well, which one are you solving for? Right, I'm solving for A, so I put A squared. All right, so B squared, 5 squared, plus C squared, 8 squared, minus 2 times B, which is 5, times C, which is 8, cosine of 60 degrees. Okay, so I just punch this out. Okay, so 5 squared is 25, plus 8 squared is 64, plus 2 times 5 times 8, that's 80, cosine of 60. 129. That's A squared. So A is the square root of that, which is also the same as X. I should say it's X. Okay, so hit my square root button. 11.36. Do they say where to round off? Let's see. Do they tell me to round off anywhere? 1 decimal place. So 1 decimal place, 11.4. Oops, don't want the square root anymore. 7.4 centimeters. All right, so one more time, and then I'm pretty much done. If I tried law of sines, you have exactly one of each letter. It's not going to work because you won't be able to cancel anything out. They gave me one A, either big A or little a, right? I got a big A. I got exactly one B, either a little b or a big B. Looks like they gave me a little b. And I got exactly one C, 8, but they don't give me that. So I'm stuck. Okay. The other kind of situation where you're stuck with the law of sines is if they give me 3 sides, so 27 and 29, okay, would be another such example. Okay. They give you all 3 sides, but no angles. So you can't do law of sines because you have exactly one of each piece of information. So you have to do law of cosines, and I'll show you how to do that tomorrow. Okay. All right. So what we're up against tomorrow is law of cosines. So again, in law of cosines, they give you exactly one of each, so to speak. So if you look at all of these examples, if you label them A, B, and C, right, they're going to give you just one piece of information, and then you'll be kind of stuck. Okay. I'll close off with 23. You look at 23 to say what's wrong. In applying the law of cosines, you got 6, 3x, and 130. The student incorrectly wrote x squared equals 3 squared plus 6 squared minus 2 times 3 times 6 cosine of 130. Okay, the reason why that doesn't work is you have to go the opposite side. It's the 6 squared that's all by itself. Okay, so it's 6 squared equals 3 squared plus x squared minus 2 times 3 times x times cosine of 130. So I'll write that down, and that's pretty much about it for 23. Okay, so you have the included angle 130 degrees. So it's 6 squared is what you want. 6 squared equals 3 squared plus x squared minus 2 times 3 times x times the cosine of 130 degrees. Okay, that's all they want you to do. They don't actually want you to solve that, but show what the correct equation is supposed to be. Okay, so that was just a little taste of the law of cosines, and tomorrow I'll do more and give you a quiz on this. Okay, so I'm done. I'm going to do my focus thing. And after I do the focus thing, we'll dismiss unless anybody has any questions about anything. So if you have any questions, you can put it in the chat now or unmute yourselves. One. Give you that. Okay, so I did what I was aiming to do, finish law of sines, sneak in just a tiny bit of law of cosines, do the rest of law of cosines tomorrow, and then quiz tomorrow. And then we're done with everything to be covered for the next exam, a week from Thursday. Okay, so schedule-wise, I'm done with 1 to 15. Okay, and I've already done a couple of these law of cosines. So this is all law of sines, finish. And I did a couple of law of cosines, so tomorrow we'll do more law of cosines, and we'll have a quiz on that also. Okay, let me check the chat. I don't see anything in the chat for now. Okay, so any other questions? If not, then we're done for the day. Okay, so anybody else with a question, please? All right, that'll be it. So we're done. Have a good day, everybody. And see everybody tomorrow. Okay, bye, everybody. Have a good day.